turn on the lights. And let's go back and work on the review together. So remember, I think I said last time that if you got everything right, not even a single point missing, then you would qualify for not having to take the final, even if the rest of people didn't average out to an 80%. I mean, to a 90%. So let me go ahead and click on this. And some of the questions might be identical to the ones you have. And I really shouldn't be doing those ones, so I'm going to be careful about that. So we did that one on paper, remember last time? And I just put in 4 because I was trying to prove that you could get more than one chance, right? But I think we actually finished it, correct?
Yeah.
Okay. So then
the max is 50. They'll say like in the details.
In the details, it says max is 50. Okay, so you get up to 50 tries, so make sure that you use your 50 tries wisely. Okay, there's this relation. There's that one. We did that one too. Okay, now we're going to find the following using a technique discussed in section 8.4. So what's 16 squared mod 55? So remember, the mod operation means remainder after dividing by something. So 16 squared is 256. And what's the remainder after dividing 256 by 55? So 55 times 4 would be 220, right? So what's the remainder after 220 compared to 256? Is anybody watching? 36, yep. So let's do 36. Submit that. Now here's the cool thing is, what is wrong with this? I just clicked the wrong button. I meant to submit. Sorry, my fault. Okay, so did it do it? Let's try again. What? What is wrong with this thing? Oh, it's still processing, still loading. Okay, there we go. So now here's the thing though. If you have already found the remainder of something squared, and you're trying to find the remainder of something to the 4th power, what is the 4th power actually? What's the 4th power of x equal to? It's equal to x squared squared, right? So to find the remainder of 16 to the 4th power mod 55, I can actually just find the remainder of 36 to the 2nd power mod 55, because I already know that 16 squared has a remainder of 36. So I can just replace this 16 to the 4th with 36 to the 2nd. So let's see, what's 36 to the 2nd? 36 to the 2nd power is 1296, right? And what is 1296 mod 55? 31. So 31. So you are allowed to use calculators, of course, when you're doing this. Now, what's the remainder of 16 to the power of 8 mod 55? Well, remember 16 to the power of 8 is just 16 to the power of 4 squared, right? So we already know that 16 to the 4th has a remainder of 31, so we can just take 31 squared. So let's do 31 squared mod 55. And we'll get that answer, which is, oops, I did it to the power of 1, my fault. 31 squared mod 55 is 26. So that one, I'm going to close that tab, I don't need that one. That one is 26, presto. And then what about 16 to the power of 16 mod 55? Well, 16 to the 16 is just 16 to the 8 squared. So I already know that 16 to the 8 mod 55 is 26. So I can just do 26 squared mod 55. So just do 26 squared mod 55, and the answer is 16. So that's cool. Perfect. Submit. Okay, let's go to this one. So remember the formula is the message to the encryption exponent mod PQ equals the cipher text, right? So when the first letter of the message is encoded, Um, so the message is key. What letter of the alphabet is the letter K? Is it the 10th or the 11th? I'll let you figure out. 11th, correct. So it is the numbers for K would be 1, 1. So when the first letter of the message is encoded, the result would be 11 to the power of E, which is 3, mod 55. So 11 to the power of 3 mod 55. So let's do that. 11 to the power of 3 mod 55. It's 11. That's kind of confusing, but I guess it just is a coincidence. So the result would be, oh, actually, I think it's asking us to break it down one step at a time. So when the 11th letter of the message is encoded, the result is 11. Bob then applies the encrypting formula. So this is just the letter K. Then Bob implies the encrypting formula to find the first two-digit block of the encrypted message is 11 to the power of 3 mod 55 equals, then this is also 11. 11 to the third mod 55 is also 11. That's weird. I mean, it's got to happen sometimes. There's always a chance it could happen. By the way, what's it called when you plug a number into a function and you get out the same number? Does anybody know? That's called the fixed point of the function. When you plug in something and just by coincidence you get the same number out, that's called a fixed point of the function. Okay, so the second two-digit block of Bob's encrypted message is, well, the letter E. Which letter of the alphabet is the letter E? The fourth or the fifth? Correct. So the second two-digit block of Bob's encrypted message would be 5 to the power of 3 mod 55, which is 15. So thankfully that was not a fixed point of that. So it equals 15. And then the third letter would be Y. Which letter of the alphabet is Y? Is it the 25th or the 26th? Remember, it goes X, Y, Z. So it's the 25th. So it'd be 25 to the power of 3 mod 55. 25 to the power of 3 mod 55, that's equal to 5. So the final digit of the encrypted message is 5. So the encrypted message that she receives would still be K because the first letter became equal to itself. But the second letter would not be E anymore. It would be the 15th letter. So let me think. Uh, K, L, M, N, O. It'd be O. And then the final letter, I've already forgot what it was. 25 to the third mod 55 would be the 5. The Y at the end would become E. So instead of being key, it'd be co. Unless I made a mistake. Oh, actually, I think I did make what click the wrong button. Sorry. I keep clicking read it instead of submit. Actually, though, I'm supposed to submit the answer as integers, not as letters. So that's my fault. So what integers does she receive? So this is actually way easier than I'm making it. I don't even have to figure out the letters. I'm just supposed to say the numbers. So she receives 11 space and then O, which was 15, and then 05, right? So that's what she receives. Except she actually would receive that as a word like co or whatever instead, probably, but it didn't ask us to figure out the letters at the end. So 11, 15, and 05. Okay, let's move on to this one right here. Alice received the following ciphertext from Bob. So remember, this is what one of our projects was about. So theoretically, you could even use the functions in that project to do some of this work. Bob had encrypted it using RSA cipher with the public key 55.3. And note that, etc., blah, 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 has a positive inverse for 3 mod mod yellow. It was found to be 27. Okay, what is Bob's message? So to decrypt Bob's message, she finds the original message by taking the cipher message to the decryption key, which is I call D mod PQ, right? So it would be um what is PQ? 55. And what's the decryption key? 27, it says. 27. So 27. So the message would be C to the power of 27 mod 55. It's a big power. Okay, perfect. To begin, Alice computes the values of all those different numbers in the ciphertext. 49, 20, 20, and 11. 49, 49 squared, 49 to the fourth, etc. And so what's 49 mod 55? It's a trick question. It's just 49. What's 49 squared mod 55? Well, we can use a calculator, so 49 squared mod 55 is 36. Okay. And then C. Well, what is 49 to the fourth mod 55? So we've done this before, so help me out a little bit. So somebody who's not said anything before, how would I find what 49 to the fourth is mod 55 if I already know what 49 squared mod 55 is? How would I do it? Any ideas? Well, since I already know 49 squared, what it is, remember 49 to the fourth is just 49 squared squared. So I already know that B is equal to 36. So I just take 36 squared and that would be the same result as if I got 49 to the fourth. So I just take 36 squared mod 55, 36 squared mod 55, which is 31. And then how do we get 49 to the eighth mod 55? How do we get 49 to the eighth mod 55? Well, I already know that 49 to the fourth squared is 49 to the eighth. And I already know that 49 to the fourth is equal to 31 mod 55. So I can just take 31 squared mod 55. So 31 squared mod 55 is 26. 26. And then now you tell me how do I find 49 to the 16th mod 55? 49 to the 16th is what compared to 49 to the 8th?
Sure.
The square of, yes, the square of 49 to the 8th. So if I just take the result of 49 to the 8th and I square it, that and do mod 55, that'll be the same as 49 to the 16th mod 55. So 26 squared mod 55 is what I need to do. And that's 16. Cool. Okay, there we go. Then 27 is equal to 49 to the 16th times 49 to the 8th times 49 squared times 49 to the first. Mod 55 equals A times B times D times E. So what they're saying is 27 is equal to those numbers. So it equals this, which equals this. It's a little confusing. But all you have to find out, it just tells you, is that A, B, C, A, B, D, E mod 55 is all that you need to find. So you just need to find about 49 times 36 times 31 times 26. Wait, 49 times 36. You don't even have C in it, actually. Just 49, 36, 26, and 16. So 49, 36. So what is 49 times 36 times 26 times 16? Mod 55. It would be 14. So it equals 14. Thus, the first letter in Bob's message is, well, what's the 14th letter of the alphabet? I think it's N. So it would be N, right? And then Alice finds the second letter of Bob's message by computing 20 with that same process. So 20 to the power of 27 mod 55. So 20 to the power of 27 mod 55. Let me just see if Google can do it. 20 to the power of 27 mod 55. Ah, okay, good. The AI could do it. The regular calculator couldn't do it though. So 15, 20 to 27 mod 55 is 15. So there we go. And then what is Bob's message after Alice finishes decrypting it? Well, we still have to plug in 20 again. Well, that'd be the same thing. That'd be 15 also, right? So she gets 14, 15, 15, and the last letter was 11. So she needs to compute 11 to the power of 27 mod 55. 11 to the power of 27 mod 55. And that is 11. Okay, that's cool. So the message is 14, 15, 15, and 11. So what letter is the 14th letter in the alphabet? N. And then the 15th letter of the alphabet, M-N-O, would be O. And then the 11th letter of the alphabet would be K. Sounds weird. So it looks like it's no, but I could be wrong though. Wow, it was right. What a weird message. Maybe this is an advertisement for Barnes and Noble's Nook. Have you ever heard of the Nook before from Barnes and Noble? It used to be an e-reader. I don't even know if it still exists or not. What?
It does.
Okay. So what's the M? Let M be the index of the 29th element of an array. So this is just testing your common sense in computer programming. Um, if M is the index of the 29th element in the array 42 through 100, then what? Which of those is a true statement? That M minus 40 equals 29, or M minus 41 equals 29, or what? Yeah, let me just check attendance real quick. 21st. So, Amani, how about LaShawn? He's here, but not here at the moment. Anthony, just only one Anthony, but not the first Anthony. Zoe is here. Isaac is here. Hold on. Isaac is here. Okay. And then Noah Anthony Johnson, you are here. And Colin Morrison, not here. Ignacio, not here. Caleb, not here. Arturo, yes. Okay, perfect. And your test for the other class is in the org.
Yeah.
Okay, so Arturo, Taylor, Logan, not here. Mercada is here. Good job. Okay, perfect. So which of those is a true statement for the 29th element? I'll give you a hint. Um, Imagine the array started with A of 0. Then the 29th element would be 28, right? So imagine the array was a normal array that just started with the 0th element. A0, A1, etc. then the 29th element would be called A28. So basically,
minus 41.
I believe so. So let me, the way that they ask it is really confusing. So basically, to find the first element of this array, you just add 0 to the first number. So the 42, A42 is really the first element, right? So you'd add 0 to the first number to find the first element. You'd add 28 to the first number to find the 29th element, right? So 42 plus 28 would be would equal M, but they're using 29. So 42 plus 28 would equal M. So that means that 41 plus 28. 41 plus 28. Yeah, right. It'd be 41. So the 29th element of the array is the first number in the array plus 28. So 42 plus 28 would be 50 plus 20, that's 70. So this just really just tests their common sense. So remember, the first element in the array is the 42th one, because that's what it starts with. Second is the 43rd, etc. So to get to the 29th one, you have to do 42 plus 28. Okay, perfect. Okay, now let's talk about this one. Ready? Determine how many times the innermost loop when the following will be iterated when the following algorithm segment is implemented and run. So I goes from A to B. So this is a critical question. In fact, I should really not help you with this because this is testing your understanding of discrete math. I goes from A to B, J goes from C to D, and then you figure out how many times the innermost loop will be run. So first of all, imagine that you're at the beginning of it. What happens when you're what happens the first time you run through it? Well, I equals A, right? And then you go into the inside, and then you run this second loop, J equals C, and then C plus 1, and then C plus 2 all the way through D, right? So let me give you a simple example. First time you run the whole process, and the first time you run the inner loop, let's just imagine that C is equal to, let's just say 3, and D is equal to, let's just say 7. 3 and 7. How many times did the inner loop run if C is 3 and D is 7? It'd run for 3, 4, 5, 6, and 7, which is 5 times. How can you get 5 from 3 and 7? Since it includes 3 and 7, you have to add 1. Basically be 7 minus 3 plus 1 would equal how many times it runs, right? So this would be equal to D minus C plus 1. That's how many times that the loop on the inside runs the first time. Well, then you go back to the outer loop and you run it the second time. So the outer loop runs for an I equals A, then it runs for I equal to A plus 1, and then A plus 2, and so forth until you get to I equals B. And once again, how many times does the outer loop happen? Well, it happened, let's just imagine A is 11, and let's just imagine B is 12. Well, it'd run for 11, and then it'd run again for 12, right? But 11 minus 12 is only 1. So you can't just subtract B minus A to get the answer. You have to do B minus A plus 1. Because if there's a difference of 1 in them, it actually runs twice. If there's a difference of 2 in the numbers A and B, it would actually run 3 times total. If there's a difference of 3, it'd run 4 times total. So the outer loop runs B minus A plus 1 times. And every time the outer loop runs, the inner loop runs within it. So however many times the inner loop runs, it's multiplied by how many times the outer loop runs, because the inner loop is inside of the outer loop. Perfect. Okay, now let's do this one. Consider the following algorithm segment for I equals 1 to 9, for j equals 1 to I. So notice the first loop has constants just like the last problem did. It runs 9 times. It runs when I equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that's it. But the inner loop, though, has a variable in it. It runs only from 1 through I. So let's answer these questions it asks. It's actually just trying to get you to think about it mentally. How many times will the loop on the inner loop be iterated when I is equal to 2? So look carefully at this. For j equals 1 to I, how many times will that loop be iterated when I equals 2? How many times will that be iterated when I equals 2?
Twice.
Twice, because it goes for j equals 1 to I, so it'll go 1 to 2. So it'll happen once and then the second time too. How many times will the inner loop be iterated when I equals 3? It goes from 1 through I, so it'll go 1, 2, and then 3 times. How many times will the inner loop be iterated when the whole algorithm is implemented and run? Well, it'll be iterated when I equals 1. It'll go from 1 to 1, which is only once. Then it'll go from 1 to 2, which is twice, then 3. So the total number of times that the inner loop will be run will be 9 different sessions. And the first session that happens will only be run once. The second time it runs, it'll be run twice. Then all the way to the ninth time the outer loop runs, the inner loop will be run 9 times. So the inner loop will be run a total of 1 time plus 2 times plus 3 times all the way through 9 times. And who remembers the formula for adding the numbers from 1 through 9? Who remembers the formula for adding the numbers from 1 through 9? What do you have to do to add numbers from 1 through a certain number? Remember that programming project that you had to do? The fast way and the slow way? I'll give you a hint. There's something divided by 2. Yes,
Be n times n plus 1 divided by 2.
correct. N times n plus 1 divided by 2. So it'd be 9 times 9 plus 1 divided by 2, which is 9 times 10 divided by 2. So 9 plus 1 is 10. So that's 9 times 10 divided by 2. And that'd be 90 divided by 2, which is 45. So it'd be 45 times. There we go. Okay, and how many times would this one be? This loop is the same kind of loop. It goes from 1 through n, and then the inner loop goes from 1 through I. So this is going to run 1 plus 2 plus 3 plus all the way through n times, and the total of 1 through n is just literally n times n plus 1 divided by 2. So the first answer is an actual number of 45, but we use the formula n times n plus 1 divided by 2. The second one, we actually type the formula in for the answer. Perfect. Okay, now let's try to do this one. A study was done to determine the efficacy of the 3 different drugs A, B, and C in relieving headache pain. Over the period covered by the study, 50 subjects were given the chance to use all 3 drugs. The following results were obtained. And then it shows the results. So note that some of the subjects who reported relief from drug A may also have gotten relief from drugs B or C. So this is exciting. How do I figure out the answers to this question? How many people got relief from none of the drugs? That's a critical question. Well, look, 42 people got relief from at least one drug. and there were 50 people total. So that means that 8 people were left. There are only 8 people left who did not get relief from at least one of the drugs, which means that those 8 people got relief from none of the drugs, right? So let's go ahead and fill out this diagram down here. So by the way, I think that the title of this chart should probably have meant to say sample of subjects instead of sample of students, because there's nothing in this problem talking about students at all. So I think the title just meant to say sample of subjects instead of students. So there's 8 people who go outside the circles, 8 people who got relief from none of the drugs at all. All right. Okay, perfect. And let's see here, right here. How can we figure out the rest of it though? That's going to take a lot of logic. So what does it mean if 21 people reported relief from drug number A? What is 21 reported relief from drug number A? What does that mean? That means that in this circle right here that has A, there's 21 total numbers in it. This is kind of like playing Sudoku or something like that. We have to figure out a way to put the numbers so that all 4 boxes within the circle A add up to 21, right? And then what about how many people reported relief from drug B? That's also 21. Drug C is 31. But then let's look at the further details though. 6 people reported relief from both drugs A and B. So that means the part that's in common to A and B. What part is in common to A and B? What part is in common to A and B? Only these 2 spots. Those 2 spots have to add up to 6. Those 2 spots have to add up to 6 because 6 people reported relief from drugs A and B. How many people reported relief from both drugs A and C? Where's A and C? That's those 2 spots. Those 2 spots have to add up to a total of 13, right? And then these 2 spots with between B and C, these 2 spots right here, they have to add up to a total of 14. So let's make a little drawing. Unfortunately, I can't really write on the computer screen itself, but we have six for the top one, 13 for the lower left, and 14 for the lower right. 6, 13, and 14. That's 6, 14, and 13, right? No, 6, 13, my fault. 6, 13, and 14. So how can you put the number 6 into 2 spots, like this spot and this spot, and then the number 13 into 2 spots, this spot and this spot, the number 14 into 2 spots, like that? Because there's 4 spots total. 1, 2, 1, 2, 3, 4. How do you put the number 6 so that total of these 2 spots is equal to 6? And then you put the number 13, so the total of these 2 spots is equal to 13. Then you put the number 14, so the total of these 2 spots is equal to 14. That's the puzzle we have to solve. So can you solve it? So can I put 13 in the middle square? Maybe and then like 0 in that square? And why not?
6 is smaller than this.
Yeah, because this has starts to 6. So the biggest that I could possibly put in the middle is 6, right? There's actually probably many different many different ways to put the numbers actually. So we have to think about the other parts of it as well. 21 reported relief from drug A, 21 reported relief from drug B, and all those things like that. So there's actually more variables involved in this. So do you remember the time when we talked about the law that says A union B is equal to the number of things in A union B is equal to the number of things in A plus the number of things in B minus the number of things that are in A intersect B. Do you remember that? Law of multiple exclusions. Inclusion, yeah, right here. Let me show this law to you right here. Ready? The number of things in A union B is equal to remember that they call this the cardinality. So you might the difficulty of problems like this is why they have rules like this. The number of things in A union B is the number of things in A plus the number of things in B minus the number of things that are in both A and B, right? And then it can also be extended to 3 sets as well. The number of things that are in 3 sets is equal to the number of things that are in each individual set minus the number of things that are in any combination of both sets plus the number of things that are in common to all 3 sets. Like that. So I've got a suggestion. We don't know how many things are in common to all 3 drugs, right? We don't know how many people were benefited by drug number 1 and drug number 2 and drug number 3. So we don't know what the number is in the middle. But we can use that formula to calculate the number in the middle just by using algebra. If I move this term right here to be by itself, and I move these terms to the other side of the equation, then let me write these numbers down on a piece of paper so that I can point to them on the screen. So look back at the question. How many things were in the how many things reported from drug A? 21, 21, and 31. So 21, 20, so again, 21, 21, and 31. 21, 21, and 31. That's how many people benefited from each drug individually. 21, 21, and 31. And then how many people benefited from both drugs A and B? 6, 13, and 14, right? 6, 13, and 14. 6, 13, and 14. So that means that these numbers right here are 6, 13, and 14. And then what about that last number at the end? The ones that are in common to all 3. We don't know what that last number is, so that's like X. So plus X. And then we know how many people benefited from any of the 3 drugs, which was 42, right? It told us that 42 people repeated relief from at least one of the drugs. There's 42 people in the entire set of circles. So what we have is an equation like this. We have, this is going to be our last problem for today. We have an equation that says 42 equals 21 plus 21 plus 31 minus 6 minus 13 minus 14 plus X, right? And X is the number that goes in the middle circle. So can you solve that equation? That's easy to solve, right? Let me take a picture of it real quick. And once you solve that equation, you can instantly solve the other equations. That's why this equation is so important. Because once you know what number goes here, let's say, for example, that the number that goes here is 5, then you can instantly find the other 3 numbers because we know that the total is 6 right here. So if this number is 5, this would have to be 1. And this would have to be, now I don't know if it is 5, but I'm just making that up. But we can instantly find all the other numbers once we find that number in the middle. That's how that middle number is crucial. So we can continue with this problem next time. And which question was that on the review? 23. So good job, everybody. So now you understand why we had all those strange different topics that we learned about during the class. Because when you get to a puzzle like this, the point of this is it's almost impossible to figure out those numbers just using common sense. So sometimes you need a formula for it. Or a way of doing it, at least. Good job, everybody. So I'll see you again on Monday.